Hello students, I hope you all are fine. So students, today we will discuss about the general introduction of unit 9, that is Amine. Okay, that is the unit of class 12th. Okay, so student, today we will see about the Amine. What is Amine? Amines are the derivatives of ammonia. I hope you all know about an inorganic compound, that is ammonia. Ammonia is one gas. Its formula is NH3. Okay, this one is ammonia. So student, amines are derived by the ammonia. Okay, how? Like ammonia, nitrogen is here. Nitrogen is central atom and its atomic number is 7. Its atomic number is 7. If I talk about its electronic configuration, then it will be 2 5. Okay. Electrons in K shell, there are 2 electrons only, and in L cell there are 5 electrons. Okay. So students, electron present in outermost shell, these are known as the valence electrons. These are known as the valence electrons. Okay. How many valence electrons are there? 5. Means it can form maximum 5 bonds. But if you will see here, in case of ammonia, nitrogen, its valence electrons, how many? 5. 5 valence electrons are there. 2, 3, 4, 5. Okay. For completing its octet. Octet means there should be 8 electrons in outermost shell, in valence shell. Okay. But there are 5 only. So it needs 3 more electrons. 3 more electrons. You know very well, every element make bonds for completing its octet, for getting stability. If there are not 8 electrons in valence shell, then either it will attract the electron or it will lose the electron, or sometime it will share the electron. Okay, means it will form bonds. Okay, so students, for completing it need 3 more. And here, if I talk about hydrogen atomic number is 1 in first shell, in K shell. We can fill maximum 2 electrons. So, electron only 1 here, so we can fill only in K cell. Okay, I hope is it clear to you. So, student, there is only 1 electron. Hydrogen. 1 hydrogen is having total hydrogens are 3. 1 hydrogen is having only 1 electron. Okay. So student, they can do sharing. Mutual sharing they will do. Mutual sharing. One bond, this nitrogen will form with this hydrogen. One bond with this hydrogen and one bond with this hydrogen. They will form 3 bonds by mutual sharing of the electrons. And the bond which is formed by mutual sharing of electron, that is known as the covalent bond. Means it is forming 1 bond, 2 bond, 3 bond. Okay. So here 3 electrons consumed in bond formation. Yes or not? I hope you are getting my point. Here 3 electrons consumed in bond formation. So this pair of electron, that is non-bonding pair here. Non-bonding pair means that is known as lone pair. So how many lone pair? 1 lone pair. Okay. So student, this is the structure for the ammonia. In case of ammonia, nitrogen having one lone pair of electron and three bonds. Okay, so three bond pair it is having. So if I talk about its hybridization, then what will be the if I talk about hybridization, then what will be the hybridization here? So students, in very simple way, how can you tell about hybridization? Hybridization by tricks. Simply you can calculate by this trick. Hybridization is equal to the number of bonded atoms plus number of lone pairs. Okay, these two things you will see. Okay, if their sum is 0, it will be not 0. If their sum is 2, then hybridization will be sp. If their sum is 3, then it will be sp2. If it is 4, then 1 orbital of s, 3 of p, sp3. If this sum will be 5, then sp3 in 3, there are only 3 orbitals in p. There are only 3 orbitals in p. So, next electron in D. If this is 6, then sp3 did. Means like that. So here you can see in case of ammonia you can see here how many bonded atoms? Bonded atoms are 1, 2, 3. 1, 2, 3. 3 hydrogen atoms. So here bonded atoms are 3 plus lone pairs. How many lone pairs? Only this one pair, no? Only this one pair. This is non-bonded pair. So that's why it is known as the lone pair. So only one lone pair is here. So this sum is 4. If this sum is 4, means what will be the hybridization? sp3. Hybridization will be sp3. Hybridization is sp3. Okay, students. So in case of ammonia, hybridization is sp3. Okay, and if hybridization is sp3, if hybridization sp3 you all know very well about the geometry for sp3. It should be the tetrahedral, but here it is not tetrahedral. Geometry is tetrahedral, but its structure will be the pyramidal. Pyramidal structure. Why? Because one lone pair is here. Clear or not? So that's why this one structure, this one only. This is the pyramidal structure. Okay. So students, bond angle for sp3 hybridization, this angle should be 109 degree 28 minutes. This should be the angle for tetrahedral, okay, for sp3 hybridization. But here this angle is not 109 degree 28 minutes. Okay, so it is 107. Why is it? I think in 10th class you have studied about the Vesper theory. What that was explaining? That was saying that lone pair repulsion. Lone pair repulsion will be greater as compared to the lone pair bond pair repulsion. This will be greater as compared to the bond pair repulsion. Okay, yes or not? So students, if repulsion will increase, then angle will decrease. Your angle is inversely proportional to repulsion. Angle, repulsion and bond angle, they are having reverse relation. If one will increase, then second one will decrease. Means they are reciprocal of one another. Okay. So students, they are inverse. So you can see, in case of, if there is no lone pair, then angle will be 109 degree 28 minutes. But if any lone pair is there, so then that angle will decrease. So in case of the ammonia, one lone pair is there, so here bond between lone pair and bond pair. So lone pair bond pair repulsion will be there, lone pair bond pair repulsion will be there. That's why this angle will decrease, and that angle is 107 degree. Okay, this is all about the ammonia. This is all about the ammonia. So student, ammonia is NH3. It is having 3 bond pairs and 1 lone pair. Its hybridization is sp3. Structure is pyramidal and angle is 107 degree. So I told you, amines are derivative of ammonia. How they are? Ammonia. Now you all know very well about ammonia. NH3. Ammonia is NH3. Ammonia, NH3. One lone pair is here. One lone pair is here. So student, if one hydrogen is replaced by, any R group means any alkyl group, then it will convert into amine. It will form amine. Like, if I write like this, ammonia, this is one hydrogen, this one is second one hydrogen, third one hydrogen, I am replacing with R group. Okay, so now student, it is amine, RNH2. Here also nitrogen is having one lone pair of the electron. So this one is known as the amine. And what type of amine? Primary amine. We will discuss about primary, secondary also. What are they? Okay. Then student, if I am replacing one more, okay. If I am replacing one more hydrogen I will replace, okay, by which? By R, by alkyl group. Then what will happen further? We will get structure like this. H. So here you are taking R. This is R2NH. Here R groups are 2. These R groups may be same or different. Okay, these may be same or different. R2NH. Lone pair as it is. Okay, keep in your mind that lone pair is as it is. So if two hydrogen I replace by alkyl group, then it is also amine. But what type of amine? Secondary amine. It is the secondary amine. Okay. Now, if I replace one more, hydrogen by alkyl group. One more hydrogen by alkyl group. These all 3 alkyl group may be same or different. So this one, This is R3N. Lone pair as it is. Lone pair is as it is. Okay. So student, it is known as tertiary amine. It is known as tertiary amine. Yes or not? So students, firstly we were having ammonia. By replacing hydrogen of ammonia by alkyl group, we are getting amines. Okay, so we are deriving amines from ammonia. That's why they are known as derivatives of ammonia. If only one hydrogen you are replacing, then you are getting primary amine. And if two hydrogen you are replacing, then it is secondary amine. Okay, and if you are replacing one more, then it is known as the tertiary amine. I hope it is clear to you. Then student, yes. So students, this is the amine. Okay, amines. What is amine? Amines are derivatives of the ammonia. They may be primary, secondary, tertiary. Sometimes they form quaternary salt also. Clear? Yes. So now we will talk about structure of amine. Till now you have seen about the structure of the ammonia. Now we will discuss about structure of amine. What was the structure of ammonia? Nitrogen was having 5 electrons in outermost shell. Okay, hydrogen was having 1 electron in outermost shell. They were doing mutual sharing, they are forming bonds, and this was the lone pair. This was the lone pair. Okay, that was the structure. Are you making any type of change when you are doing formation of the amine? No. Arrangement are as it is. Only you are replacing hydrogen by alkyl group. Like this. Okay, arrangement is same here, na beta. So here also same thing. Hybridization, number of bonded atoms, plus number of lone pairs, Clear? So bonded atom. In this also there are 3. 1, 2, 3 plus lone pair. Also same. 1, 4. If this sum is 4, then hybridization will be sp3. So here also hybridization is sp3. Here also 3 bond pair, 1 lone pair. So structure will be pyramidal. Same structure was in ammonia, no? Yes. So here also structure is same. That is pyramidal. But there will be a little bit difference in it in their bond angles. Okay, their bond angles will greater than 107. Why? Because these R groups are the bulky groups as compared to the hydrogen. So repulsion, definitely repulsion will be here between lone pair and bond pair. But that repulsion will be less. Why? Because this R group is larger, okay, as compared to hydrogen. So repulsion will be less here. Okay, if I talk about the tertiary amine, R3N. Okay, so here this is tertiary amine. So student, here also other things are same. Bonded atom 1, 2, 3. Only you are replacing. You are not doing any change in structures. Okay, their arrangement. Plus lone pairs are also same. So hybridization also same. Their structure also same. Only there will be little bit difference in their angles. Okay, if I talk about bond angle, in case of tertiary, then it will be 108 degree, not 7. 108 degree. Why? Because these R groups are the bulky groups. R groups are the bulky groups. So here, as compared to hydrogen, So here repulsion will be less. So that's why this angle is less than 109 degree 28 minute, but slightly less. It is 108 degree. Clear students? So I hope structure is clear to you. Okay, so amines, either it is primary or it is secondary or it is tertiary, all amines are having hybridization sp3. Their structure is pyramidal and their angle in between 107 to 108. Tertiary are having 108 degree. Okay, so amines are the derivatives of ammonia. Okay, when hydrogens of ammonia are replaced by the R group, okay, if only one you are replacing, then it is primary amine. If you are replacing two, then it is secondary amine, and if you are replacing three, then it is tertiary amine. Okay, so I hope it is also clear to you, either it is primary, secondary, or tertiary. Okay, and simply you can learn like this. If this nitrogen R group is alkyl group, any alkyl group means this bond of nitrogen is forming with carbon. Like this R group may be ammonia, it may be, sorry, not ammonia, methyl. Okay, it may be methyl, it may be ethyl also, it may be propyl also. Okay, what I mean means here bond between nitrogen and carbon. Bond between nitrogen and carbon. Okay, students. So here you will see, if nitrogen is forming only one bond with carbon, then it is primary. If nitrogen is forming two bonds with carbon, it is secondary. If it is forming three bonds with carbon, then it is the tertiary. Okay. For example, this is aryl benzene, aryl group, aryl amine. Benzene ring is here. Okay, and its common name, it is known by its common name, aniline. Okay, are you able to tell it is primary, secondary, or tertiary? You will see. This carbon, nitrogen. So this nitrogen is attached with only one carbon. So that's why it is primary. What type of amine? Primary. Tell me, it is primary or secondary or tertiary? So nitrogen. You will see nitrogen. If nitrogen attached with one carbon only, then it will be primary. If nitrogen is attached with two other carbons, then it is secondary. If three, then it is tertiary. In this way you can distinguish. I hope it is fine. It is clear to you. So students, let's see. Here nitrogen. This is nitrogen. You can write like this. This nitrogen. 2 CH3. CH3 twice. So this nitrogen is forming bond with other one carbon, two carbon, and this one carbon, three carbon. So it is tertiary. It is tertiary. I hope it is clear to you what is primary, secondary, and tertiary. Okay. So student, now we have discussed about the structure of amine. Okay, and means this is derivation of the ammonia. Okay, primary, secondary, tertiary amine mean classification of amine also. Okay, so now we will discuss about some method of preparation of amines also. So if I talk about method of preparation, method of preparation of amine. How can you prepare? How can you prepare? Before that, you should know that why we are studying this chapter, why we are studying this unit, where do we need this? Okay, so students, in many drugs, in our proteins also, okay, in many polymers also, amines are present. Amines are present, okay, in many polymers, in many biomolecules also, amines are present there. So we should know about them. Clear? So students, how can we prepare it? First method, by reduction of nitro compound. First one is reduction. Reduction of nitro compounds. What do you mean by reduction? Reduction means reduce, either decrease in oxidation number or addition of hydrogen or removal of oxygen. Okay, like this you can do, or gain of electron, or gain of electron. So if you are having the nitro group means R, NO, NO2 group. NO2 is nitro. Okay, you want to do reduction. So student, for reduction you need reducing agents. Okay, some common reducing agents are, you need not to can any reaction. Reducing agents. Reducing agent like lithium aluminium hydride. Lithium aluminium hydride is the highly, or we can say strong reducing agent. Sometimes we use sodium plus ethanol also. We use sodium borohydride also as reducing agent. We use SN plus HCl also sometime Fe plus HCl. Okay, and sometimes hydrogenation H2 in presence of palladium or platinum, like that. So student, if you do this reaction in either in presence of, you are doing hydrogenation in presence of palladium, okay, then also this nitro group will reduce and it will convert into the amine. Means this nitro, very simple to write the reaction, this nitro will convert into NH2. That's it. Nitro you will convert into RNH2. Only this change you will make. Only this change you will make. Okay. R group will remain as it is. R. Your R, I am not making any change in it. Okay. R will be as it is. This nitro will reduce and it will convert into NH2. Okay. You know now. Here oxygen remove, and removal of oxygen is reduction, and at place of that you are adding hydrogen, and addition of hydrogen is also reduction. Okay, so you are doing reduction of the nitro group. Okay, and you are getting amine. For example, if you are having CS3, CS2, NO2, like this. Okay, if reducing agent is given, you are doing hydrogenation in presence of palladium. Okay, so what will you do? You will change only this one. You will change only this one. This R group, it will remain as it is. It will remain as it is. Only this NO2 group, only this NO2 group will change into NS, into NS. Means nitro can be reduced into amine. Okay, either by hydrogenation or sometime you can use, means same process you can do in presence of Sn plus HCl. Either you can take this or you can take this one also. The same task you can complete in presence of Fe plus HCl also. Fe plus HCl also. Okay. One important question from here. Which one, means you can do reduction of nitro either in presence of hydrogen palladium or in presence of Sn plus HCl. Same work you can do in presence of this one also, or you can do in presence of this one. But which one is most preferred? Which one is most preferred? So this reagent Fe plus this reagent Fe plus HCl, this is the most preferred reagent. Why is it? Because student, here we need to provide HCl. We need to provide because here we need to provide this HCl. In very small amount. In very small amount. Okay. For initiation of for initiation of reaction only. Means we need hydrochloric acid only for initiation of reaction. Okay. After that, in reaction mixture, it form. We get HCl. HCl also form in reaction mixture. During the reaction, it form again and again, and that HCl can be used. So reaction will be continued. Clear or not? So we need now to provide this HCl in large amount. In case of this reagent, we need to provide HCl in very small amount. Okay, we need it only for initiation of the reaction. We need to initiate the reaction only. Okay, for that we will provide HCl, and again and again, means continuously HCl will form during the reaction also, and that HCl can be used for further reaction. Okay, so reaction will be continue till that best yield you do not get. Okay, so students, some more methods are also here. Okay, but today only one we will discuss. I hope all points are clear to you. Okay, so thank you, have a nice day.